Hey YouTubers, Electric Adventures here with the next episode in my Let's Make a Retro Games series, and episode 10 is collision detection. So sorry it's been a little while between these, but I just basically had some trouble getting things recorded and progressing it. So I wrote the code ages ago. Tried to make this as clear as possible for all you guys, so we'll start with a little bit of a concept using PowerPoint. So it's only a couple of slides to go through. So first, when two objects collide, so we've got two objects A and B. I like to treat them as rectangles because we are only dealing with 8 bits computer here, and you've only got so much time to figure things out. So it's best treating things as rectangles. Now they can be different size rectangles, so each of them will have an X and a Y position and a width and a height. And as far as working out whether they collide or overlap, as you can see these two shapes are, that's the situation when we have a collision, where either of these rectangles, or where these two rectangles are overlapping each other, is when, if you think about it, the X of the first one plus its width, that new X coordinate is inside the range of X2 to the X2 plus the width, so as our diagram is illustrating at the moment. So when this coordinate here lies anywhere inside, plus its width lies anywhere inside this rectangle, that's where we're going to get collision. Sounds complicated, sounds hard, as if it's going to be hard for us to figure out, but it's actually, it only involves one calculation, or two calculations per X and Y. So 2 for X and 2 for Y. Sorry, I'm probably sounding confusing here. But anyway, our first situation, so sometimes rather than test whether they're actually colliding, let's work out whether they're not colliding. And if they're not, then you can exit straight away because you know they've missed. So if the first object's plus its width is less than the X position of the B object, then they're not going to collide. So it's all the way to the left and there's space or even just touching here. It's not overlapping, so we haven't collided. And then our next situation, which is actually our last situation, is the first object larger than the X plus its width, so larger than this value. So all we have to do is do two comparisons. I'll just go back. So your first comparison is to see whether X plus its width is smaller than X2, and X plus X2 is smaller than X1. They're actually the same calculation but with a different set of values. And then to do the Y, you just repeat exactly the same thing, except you put Y where the X's are. So that's the end of our slideshow part of the presentation. Let's get some code up so I can show you what words I'm talking about. So opening our code as we left it last time, we have our game here. So what we'll do, we'll compile this and then we'll run it just to remind everybody where we're up to. So here's our Mega Blast. So we can press fire, we start the game, we can fire bullets, we can run into the asteroids, doesn't matter, and when we shoot, our bullets go straight through the meteors. So what we're going to try and do by the end of this episode is try and get it so that we can shoot, and if our bullets hit one of the meteors, it makes it disappear. We're not going to increment the score or make any sounds or anything like that, that'll come later. But this is a fairly complicated topic, so I thought I'd handle it in this one episode. So we'll stop that running, so that's where we are now. So now we need to actually add some code to do collision detection. And so what we'll do, we'll write a collision detection routine that we can use in a lot of places. So I'm going to put it, so here's our, because we're probably going to use it here in our move enemies routine, and I'll come back to that later, I'm going to put it just after it. So I'm going to put it just here. So using some code that I prepared earlier, as I said, I'm not going to type it all in and make a typing mistake, I'm just going to grab all the code and then we'll walk our way through it. So grab the code and pop it here. So let's go up and have a look. So make it nice and clear for you guys, because collision detection is fairly complicated, we do need to pass a few values into it. Now we're going to use the index registers, IX and IY, because commonly, and let's go and have a look at our loop here. Inside our loop, and ignore the HL that's pointing to our enemy data structure, the IX is pointing to when it starts the loop, is calculated to the current position of the sprite data in memory. So IX is already pointing to a sprite. So all we have to do is point, go back to our routine, IX to our sprite. That'll get our Y and X, because they're the first two values of our 4 bytes that indicate our sprite data. See previous episodes. And then we point IY to the second object, and then we use another 2 full 16-bit registers, DE and HL, to pass in the width and height of our 2 objects. And then our result, all we want to do is set the carry flag if we hit and clear it if we don't, and that way we can make a decision. So we're calling the routine col test. So the first thing we do is we load our first value from IX plus 0, which is going to be our Y value. Then we subtract the width. So this is our first object, IX. We're going to subtract the width of our second object from that, and then we compare that to the Y value of the second object. So if you think about it, if we've got an X here, if it less the width of the other one is less than the X value of the other one, we're in that situation where we've missed the object to the left. So if there's no carry, in other words, so jump no carry. So when we compared those values, one was less than the other, there's no hit, so we exit. And no hit goes down to here. It does X or A, which clears A, but it also clears the carry flag, so we've got no hit. So every time we go to no hit, that's just going to clear the carry flag. Next, we add E back onto A, so that actually gets our original value back. Now we could do load A, IX plus 0, but because these index instructions, they actually take up quite a few bytes and are thus slower, adding our value back again is a single byte instruction, so it's a bit faster. So it could actually be done both ways, but just think that we've reloaded our value and we've got back to exactly where we were. And all our carry flags are being affected by these, but they all get reset when we do a compare instruction, so you don't have to worry about that. Then we add the height of the first object, so you're going to have so we're dealing with Y values, so you've got Y plus the height of our object, right? And then we want to compare that also to the Y value of the second object. Okay, so actually, just to go back, the first one was seeing whether our object was past the object to the bottom. The second test is seeing whether the object is above the object to the top. So if that's true, then we haven't hit the object, so we're too far up or we're too far down. So when we've reached this stage, our Y values are crossing, but they might be in 2 different X values now, so we need to go through the same thing for X value. So we start again and we load our X value, we subtract width of the second object, we compare it to the X of the second object, and if there's no carry, then we've hit. So that means basically we're too far to the right of the object, we've missed it. Then we get our X value back just like we did with this one. We add on the width of the first object, so once again X plus our width, and then we want to see whether that is less than the sorry, the x2 value, and if that's so, we also have a hit. And if we've got all the way through here, they should be crossing, so we set our carry flag. I really hope I've explained that clearly, but the code's here. Have a look at it, think about it, write it down on a piece of paper as well. Have a look at my attached notes. I hope they help as well. But that is our general purpose collision routine. Now, the hard part about this one is we do actually have to set up a few things before we call it. But let's get into that now. So, now we need to put it somewhere. So, now an important thing when we talk about collision detection is, and also with Z80 code and 8-bit code, you've got to be careful about how many times you loop round to things. So the best time to do your collision detection is when you're already looping around your larger list of objects. So the larger list of objects is always going to be the meteors and other enemies that we have. You could have a collision detection routine where you move your bullets, but if you did that, every time you moved your bullets, it would have to loop round and look for any of the active objects and see whether they collide. You see what I mean? You're adding extra loops. Whereas if we put it where we're already drawing our objects and then do check whether it collides with the other limited things, which are either going to be our bullet or our ship or the bottom of the screen, they can be done inside our main loop. So up here, we've already got our detection for the bottom of the screen here, so we don't need to worry about that at the moment. But we already have our loop, so we're already going through our objects, and we've already determined whether the object's on the screen and hasn't gone off the bottom of the screen. So it's the perfect position to put our code. So let's get the first part of it. So just getting my correct position. Right, so at this position here, we've been through and determined, and the object is still existing, so, and we have moved it. So what we'll do is we'll add a couple of lines here just to put a bit of space. Now we want to check our bullets. So we only ever have one bullet on screen. So if we add this little bit of code, and notice I'm keeping that in view so you can see where it ends up. Let's just move up the screen a little bit so you've got a bit more room. Right, enemy object has been moved. Now do collision detection. So we know the enemy object has been moved and it's still on the screen. Oops, we need to do a little correction here though. We don't want, so here where the sprite's been cleared, we don't want it to go and do the next bit of code. So we need to add a little bit of code here, which I'm going to type in. So we store our current A value here, which is 209, which clears the sprite. And we want to jump relative and go to ME2, which is our go to our next shape. Okay, so that's a little bit of code to add there. And exit. So now we'll only ever be here when the shape is still on the screen. Right, we go and set our IY to sprite total +8, which is our bullet Y position. We go and get that value and just check that it's not 209. If it's 209, there's no bullet on the screen and we don't need to do anything, so we can go straight to our next object there. Now we may have some other checks later, but we're just doing this check for the moment. Now we're going to have to call our collision detection routine, and very important thing we need to do, because you don't know what's going to be changed inside the routine, so it's best that we protect and save our registers that we're going to change. So we're going to fill these up with information and use them. As you notice down here, we're using HL for something, so if we didn't save our HL, it would be we would change it and we lose our value. So what we do, we push them onto the stack, and we push D onto the stack, and then later on we need to remember to pop off the values as well. You've got to make sure you do them balanced. So I like to always code them completely up and then put my code in between. Now we need to set our meteor size and bullet size. Now later on, the size of the meteors will be determined on what type of object it is, but at the moment we only have meteors. sorry, pasting in code, got a bit of extra space. So what this is saying, we're just treating them purely as rectangles at the moment. So they're 14 by 14 pixels, and our bullets are 2 pixels wide and 8 pixels tall, because they're tall and skinny. And remember, we've already set our IY. Our IX is already pointing to our meteor. So we've set everything up that we need to call our collision test routine. So we call our collision testing routine, and then we go, we're done. So after we exit, we pop off those values there. Remember, the value is stored in our carry flag, so we don't need to worry about destroying anything else. We don't need to do our decision straight away. And we want to jump when there's no carry, which means there's been no collision, to ME2. So at this stage, we actually have collided. So what we need to do, and as I said, for the moment we're just going to keep it really simple, we need to clear both our bullet and our meteor off the screen. So 209 is our thing to make a sprite disappear. We set the Y coordinate of the bullet and the Y coordinate of the meteor, which basically gets rid of both of those. But also remember, with meteors we have our enemy table, so we know whether an enemy's active without going through the indexes. So we need to clear out A, so it is definitely 0, because we used it a minute ago. Store it in our HL, which is pointing to our active enemy, and we're done, and it should make it disappear off the screen. Now I'm just going to add this little comment in later so you know what we're going to do in other steps. So later on we're going to increase the score because we've hit something, so we need to add to export, make an explosion sound, and animate the enemy. So instead of just disappearing, we might want to animate through a couple, put it into a different state and animate through a couple of stages, or maybe make 2 meteors fly out or something like that. We'll work out that later as we go through the rest of the game. So we've added all the code we need to for this episode now. So let's save it and see whether I've made any typing mistakes. Okay, our build is successful. Let's bring up our emulator, and I'm just going to right, and press play. So here's our starting Mega Blast screen of those things. So we can move our ship, and as I said, we do need to work on the random routine, and we can fire. Now let's see if I can fire. Oh, there we go. I can actually shoot the meteors. Now it said there's no collision detection with us, so there's no danger of getting killed. I said do need to work on the randomness sometimes, but that's alright. We're going to make that one. Let me see, I can hold down the fire button and get a repeating fire. We've died then. Right. We've done basic collision detection. So now we can use that collision detection routine in more places later on. Although the collision with the main ship's a little bit easier because all we have to do is the thing past a certain point, but sometimes it's easier just to call the same routine. So probably in the next episode we'll do the collision with a ship, and we'll add some scoring just to make it a bit more exciting. Alright, I hope you've enjoyed this episode of Let's Make a Retro Game. Now the companion source code for both Coleco and MSX will be available on my website, put a link down below, as well as a full article going through all of the steps we've been through today. And also feel free to ask questions down below in the comments and I'll answer them as best as I can. So I'm Electric Adventures, thanks to all my subscribers, thanks for watching, and I'll catch you next time.